Entonces, ha llegado el momento de comenzar la sesión 2 de comunicaciones, que, como habréis visto, tiene 8 comunicaciones y una conferencia inicial, que es la que nos va a dar ahora Nina Rappaport. Sí, que me ha pasado, le he pedido que me pasase unos datos de su currículum. Se entiende como escritora de arquitectura, editora y profesora. Es autora del libro Vertical Urban Factory, a punto de ver la luz esta primavera. La exposición sobre este tema, con carácter itinerante, tendrá lugar en Lausanne el próximo mes de abril. Es directora, además, de publicaciones de la Escuela de Arquitectura de Yale y tiene su labor docente sobre la industria y la ciudad. Su ponencia va a tratar sobre Vertical Conveyance of the Vertical Urban Factory, algo así como la comunicación vertical en las factorías urbanas verticales, la importancia, evidentemente, de esa comunicación vertical.
Good afternoon, everyone. Can you hear me? I'll do mostly talking here, but I'll move there. Thank you so much for inviting me to this conference in Madrid. I do not speak Spanish, but I do understand, so I've been very much enjoying everyone else's presentations. And I got first connected with the amazing work of industrial architecture historians and engineers through Docomomo, which I founded the New York and US chapter almost 20 years ago. And I attended the Oviedo conference where I met quite a few members here, and Rafael, who has kept in touch with me over the past 4 years through our common interests. So I'm very pleased to be back and to meet all of you. As you heard, let me see, I just want to test this. Yeah. Can you all understand if I speak about this slowly, like this? Slowly, it's okay? You understand? Okay. So I will speak slowly so you understand me. And I would like to frame my work for today on the inventions of the mechanisms of the factory, of the way that especially the integration of the interior machinery of the factory informs the design of the factory, and especially in terms of what I've been calling the vertical urban factory. I've been very interested in the way factories can return to cities and the way that we can build new factories, and to do that in cities we have to go vertically. But this isn't a new idea, as we know. It's really from the early era of manufacturing and industry. And what I'd like to show you today is the way these vertical conveyance systems work together with the vertical factory building itself. So when you think about production housed and technology housed in the volume of the factory, it's usually wrapping the machinery. It is a sophisticated system where the machinery was developed spatially with the factory building in order for production to proceed in a very systematic and regular way. It wasn't always that way, though. There was in the early 19th century, usually the factories were filled with clutter and chaos, and they were not as organized as we know in the modernist factory. But later it became what, in a way, a yin-yang, this kind of combination of an integration of the manufacturing with the building itself. And the machinery had to kind of plug into the factory, to the building, to the structure, so that it would continue to function. So we can ask today, why does verticality matter in the urban factory in particular? And what are these spatial repercussions of the typology, both inclusive of the building and in the context of the city? The production systems that I'm going to show both allow for the factory to rise vertically and for it to be rational and efficient in its organization and spatial layout. It both relied on the new integrated systems of movement for production, and those systems needed the verticality of the building as well. And they needed this verticality, especially in cities, to make the products, to streamline that processing, and to get the products out to the consumer, which in the end is all about making a profit, right? All the buildings that we've been talking about today are very capitalistic, high-end systems of consumerism. And this verticality played a significant role in these factories and in the industrialization, too, of the manufacturing products. So it's this interesting combination of the industrialization of the machinery that makes the products as well as the industries themselves. So that we see in these early examples of mills where the vertical and the urban factory was consistent with this ubiquitous production system. Building factories taller meant in cities especially they could be on less space, and there are numerous handbooks showing from the 19th century how a manufacturer could save on the land value by building multi-story factories, because the ground space was what was expensive and they could build up higher faster. One thinks of the example of Soho in New York, where there is this kind of multiple distribution of factory buildings, all with a cast iron industrial system. That's yet an earlier version of someone like Jean Prouvé, who we saw earlier, where it was metal systems that were repeated through these factory typologies. And this became an entire neighborhood of manufacturing buildings in New York. In my research, I've been looking at two types of what I'm calling the vertical urban factory. One is this integrated factory, which you see here, A and B. And in these systems, the manufacturing would either start at the top and go down, so the one on the left, A, where the goods would be brought up to the top, the raw materials would be brought to the top of the factory building, and then gradually the product would be assembled or made going down. The other is that the product would rise up, the material would rise up with the making of the product and then come back down. And this you see in numerous factories where the factory was owned by one company, right? This would be one company building their factory and using that full space for the manufacturing process. The other is the layered factory. These you would see more in the loft type buildings, say in New York, in Soho, in the old manufacturing districts, or in the garment district in New York, where you have many different factories in one building. And maybe, as in C, they occupied 2 floors, so 2 floors would be linked, or they would just be layered, one factory per floor. In these factories, they might share power sources, they would share elevators, they would share entrances, but it wasn't one factory operating that space. And this plays out very much today in terms of the smaller scale manufacturing that we see, which I won't be talking about really in this talk today. So the first vertical factories of the Industrial Revolution and pre that really had this integrated system. Siegfried Gideon in Mechanization Takes Command writes about the early mill systems that Oliver Evans designed in the mid-18th century. So already in early industrial processes, this idea of the fluid factory was something that was in the minds of the industrial engineers. Can you hear me over this noise? Yeah? Okay. I don't hear it. I just know you hear it. I don't hear it very strongly. Oh, okay, great. And what Oliver Evans did in 1775 or so was he created a full system using Archimedes screws, using pullers, using levers to produce grain. And if you can see the guy, I can walk out here, right? You can see this guy here on the far right. He's getting the grain from the fields that have been harvested, dumping it into a bucket system, and the material carries and is traveled all the way through the factory, goes up and down, and completes the full process of milling the grain all the way to here, where then it goes into the barrels and then out to the ship. So this idea of a fully integrated system was important to all manufacturing, even in the mid-18th century. And interesting is that Thomas Jefferson wouldn't give Oliver Evans a patent for a system because it was, he felt it was so competitive that it would succeed. And it did. And millwrights used this system throughout the 18th century to produce their grain. And you see it repeated and repeated again and again. And movement was constant. That's what was important to manufacturers. It was this processing to get the raw materials in and out the other end. So in terms of the systems in the factories, what we see first are those that rely on gravity, right? That just the chutes, nothing here was electrified, right? It was just using pulleys, using mechanical systems that became part of the building. And you know, of course, then later we see the use of power, we see the use of water and energy systems. Things like the bucket elevator, the buckets and the conveyor systems and the gravity systems were all just sheer mechanisms. They were things that people would hoist and pull. It wasn't as elaborate as we see today. And some of these systems became more complex. They were used in the Asturias with the coal mining. They were used to pull raw materials out of the earth. So you see these early vertical conveyance systems with the Archimedes screw that would then be able to pull something up and out. So this idea of the vertical was very important in the manufacturing process. And what's interesting is that when we all think about the Industrial Revolution, when we think about mass production and the assembly line, we usually think about the horizontal. We usually think about the assembly line as being this long process, as something that needs a large building that goes throughout the landscape. We ignore the vertical. And so what I'm trying to show is this idea of the verticality of manufacturing. And Henry Ford in Highland Park, so this is Albert Kahn's 1911 to 13 concrete frame factory that was built in Detroit. And what you see in this image is the testing of this kind of vertical system, where you can see on the far right the body of the car, the seats that were being lowered into the chassis. And they're testing out how this would operate within the factory. And it's a vertical system here. They're working, again, with levers and pulleys, and there's nothing mechanized. Nothing's running with electricity in this one. Or you see what they did in the interior, where they were using chutes that would go through the floor. So the idea of a chute that would carry the material with only gravity was something that was important here. That the chutes were contained channels, that something could go down. So you can see these tires going down the chute, and then they would be picked up by the workers. So this, a continuous processing from up to down. So again, you see this in the 1930s in the Boots factory by Owen Williams in Nottingham, England, where the interior of this building is where the activity is occurring in terms of the vertical conveyances. And you see that there are machines on the sides for lifting goods, and then these just straight drops, these chutes where the goods are dropped down. And it was a pharmaceutical company, so the mixtures were made on the ground floor, and they traveled up for packaging via a conveyor in the central hall to fill bottles or cases. And then they went on to the packing and storage and shipping. And as in Ford's Highlands Park, workers would send the bottles down from these projecting third floor balconies, and they would go down to the main floor to be packaged. Using balconies to move goods was also in Ford's factories, and you can see these cantilever balconies going out, and in the center was the train tracks so that they would lower the goods onto the trains. And this is the same in New York in the Brooklyn Army Terminal building, where they use these cantilevered balconies to lower the products down. And so what happens in these buildings is that there becomes a, oops, there's an image missing. There becomes this grid network of the factory that's up and down as well, not only horizontal. And we see this too in Ford's concepts of mass production, where working with the early system of interchangeable parts, there starts to be this assembly line process. Here, on the exterior of his buildings, this is at River Rouge, and you probably know this more as an artwork by Charles Sheeler, who documented the factory. And here the idea of enclosed bridge type chutes is what we see connecting the different parts of the factory. Or at the Van Nelle factory in Rotterdam, where glass covered bridges would connect and move the tea and coffee that was being made in the factory in Rotterdam down to the warehouses on the canal, so that there was this complete system and circulation of up and down and across throughout the factory. Also too, this is the construction of a sugar factory in Toronto, where again, this idea of these diagonal chutes would carry the products through and into their processing systems. Here we see the Diego Rivera, a section of the mural in Detroit of the Highland Park factory, and the concept of first the horizontal assembly belt and then the overhead assembly lines that were developed by Jervis Webb, also from Detroit. You can see in the background of the painting the workers taking things from above. So this creates a dynamic feeling within the factory that, again, is not just horizontal. It integrates the entire building from the top to the bottom. Here, this is the image I wanted to show earlier, where you can see this grid-like structure of the vertical factory. It's not just one straight part, but that the products go up and down. So you can see how the pieces come up to the top, and they gradually go down through the workers' work through to the assembly line, and then to the chassis assembly on the ground floor. It becomes a kind of three-dimensional grid rather than the one horizontal. And so when mechanization does take command, as Gideon said, the elevator becomes a very important element to the factory. And many people don't realize that actually elevators were invented for manufacturers. They really started out as just like platforms in the floor that would lower down or raise up. They weren't for people. And when Otis created this idea of the elevator that people could also use, what allowed it to be safe was what was called the safety brake that he invented in 1852. And this could break the elevator. It could allow it to stop, and therefore people could use it with security. And the elevator became an important aspect of the factory as well. And we all know freight elevators. We all know they can carry goods up and down. But in 1932, in the Starrett-Lehigh building in New York, the elevator was actually used to bring trucks up into the building, first trains and train cars, because the Starrett-Lehigh building was on the waterfront, still is, on the waterfront in New York. And it was built by Lehigh, who was the train company, and Starrett, who was the builder, who also built the Empire State Building. And they would offload trains that would come from New Jersey into the onto the waterfront, and the tracks would go right to the building, and the trucks would then go up into the building. And this was an unusual aspect of architecture in general, not just the factory building, because here the trucks would allow the manufacturer to have the delivery right to their door. So to develop this building, the developer said, oh, you have a first floor on every floor for your factory, so that the factory goods could be delivered right there. Another interesting aspect of the factory design in terms of the verticality is again going to the work of Buckminster Fuller, who we saw earlier. Buckminster Fuller was very fascinated with manufacturing himself. He had worked in a factory in Quebec as a young man in a mill, and he was learning the process of cotton production himself, since he was such a worldly character. And he saw that in the 50s in the United States, the factories were leaving the cities and the manufacturing facilities were becoming horizontal, that there were these boxes being created that were sealed, that were air conditioned, that were removed from people. And he said he was thinking there had to be a better way. So after he was at Black Mountain College, where we heard this morning from Luis Galeano, some students from North Carolina State saw his work and thought, let's bring him to North Carolina State and work with us down here. And so you see him here working with the textile industry students and the architecture students, trying to figure out a way to make a new vertical factory. He didn't want to repeat these horizontal sheds in the landscape. And so he created what he calls the fountain factory. And in the middle, just like the Dymaxion house, he had a tube system that would rise up and would carry all the services. But it wouldn't just carry the services, it was also a vacuum system that would pull the raw cotton up into the factory. So that you see here in this drawing, bales of cotton being brought in by truck into the factory, and they would go, the cotton would then get unloaded and be carried up into this interior structure system that was then divided up. And you see here the resulting factory design that was never built, but it pulled in the cotton, it would go up to the top. He created his same Dymaxion dome system using a gridded network of steel. And the floors were rings, if I can. So it was a circular system that would rise up. And just like the early factories, the material would gradually work its way down floor to floor, but he could also place elements in between the gridded system. So here you could see, again, this idea of the three-dimensional functioning factory, not just the horizontal system. And one fascination I've had lately is something that I really have seen nobody write about, which are these vertical spiral chutes. And one of my friends said, oh, I'm really a geeky person and I don't know it. But the idea that the factory had to have, the vertical factory had to have a system that could work to carry the materials. You can just imagine these industrial engineers or manufacturers trying to come up with a way to get their goods from the top to the bottom without too much effort, in a simpler system than someone like Oliver Evans did in the 18th century. And so they started to combine these forms of the straight chute and then this idea of a circular system. So this, when you think about a straight chute in a factory in the 19th century, it really takes up too much space, right? You're going across an area, just like a staircase. So the idea that you could create a circular system is what started to happen. And it's still a chute. And this is an image from like an encyclopedia of the 19th century. And you can see how the worker would put the good in the top, and then the spirals would go down from floor to floor through the building. And it was contained just like a slide, but it would turn. And what the turns would do would be to control the material. The turns would slow down the process. So instead of the straight chute where you just go, throw something out, the spiral would actually direct and control the speed so that you can control how fast something went. And then you can see how it also condenses the space, that spiral allows a smaller amount of space for that material to travel. So this became a very popular item. There were numerous patents that were taken out. You can see here, this is one from about 1906. And the idea of this curve would then have to be geometrically configured for the speed that was wanted. And the material would then travel down through the floors in these factories. Again, another patent taken out for a system that was a conveyor, but also this spiral chute. So you can see numerous patents taken out in America for these systems where this form would keep returning and returning in order to carry the goods through the floors. So we see here it in operation. This is in a mill factory where you can see the barrels on the chutes themselves. And the chutes, just like a conveyor, like a flat roller conveyor, had rollers on it. So that's how the goods would roll down through the factory building. These were repeated and repeated. And what was interesting too is that they could be used in these high bay buildings. And a high bay is like a double height factory building where it could also be used to move goods or to store goods in shelving. And here's an example of a later version, but of the same kind of thing. And you can see this one has wheels. So it's all through the 50s and 60s, manufacturers were making these spiral conveyance systems that can then just be inserted into the factory. The same way engineers were making staircases, spiral staircases that you could buy off the shelf and just insert in your house. So it became a very standardized industrial system. So this is one from a brewery in Toronto, the exact same kind of system. And what became very fascinating to me is to make these connections between the idea of conveying material through a spiral that was an individual standalone object, but also the potential for a building to take on this form. And this we see, this is the spiral ramp system in the Fiat Lingato factory. So at Fiat, we see the conveyance system becoming the building, so that the building actually takes on this spiral form. And there they would use carts to move goods up to the top of the building, and then later to move the cars up to the top when they were completed to end up on the test track on the roof. So this idea at the building scale that the spiral becomes the building as these movement systems become part of the features of the factory is what we see. These unique radiating concrete ribs here took the cars to the roof track, and they delivered the rolling vehicle into this awkward space actually that was the rooftop track. It rose above the city, and Mate Trucco, the engineer of the building, capitalized on the production process in a way to enhance the building design as well. So the last project I want to show is a series, the Moscow bakeries that were designed in 1931. And these are actually some of the most impressive functionally and formally. They were designed by the constructivist Maraskov, and one is still in operation. And this is where we see how bread baking became a new system of production, because it had the masses of people who were moving from the countryside in Moscow had to be fed. And he employed a circular conveyance system that provided continuous automatic production of bread from the top of the factory down to the loading docks in a vertical production system that we could say is similar to Oliver Evans from the 18th century. And for these round factories, the flour would arrive by train on tracks adjacent to the factory, so it could be directly delivered to the basement warehouse. And they used conveyance systems like this in order for the final bread to be delivered. From the fourth floor, the dough was moved through these circular chutes, and then the fermentation process occurred. And at the end, it fell through slats, which as we see here, to the second floor through the cutting facility and made into loaves. So what you can see in this entire system is that the actual processing totally defines the building. So rather than that of this horizontal open space that we normally think of a factory, that the building actually takes on the form of this almost spiral process. So that the loaves move, that the bread moves from top to bottom in the processing, from the dough to the fermentation to the baking and to making the loaves. And you can see the little truck that's leaving the factory space. And to me, I feel very much that Buckminster Fuller might have seen this to create his idea for his vertical mill. So directing the form of the building, these manufacturers and their architects are reacting to the process and incorporating the process into the design. The factory becomes the vertical process machine, not just a container for it. It was a holistic production, industrialized and engineered in order to get the goods into the consumer production line. Thank you very much.
Muchas gracias, Anina Rappaport. El que tenga interés en este tema y quiera ampliarlo, mañana la profesora Rappaport va a dar una conferencia en el Departamento de Proyectos en el Máster de Proyectos Arquitectónicos.